Hello and welcome to Tomorrow's Tech by IDTechEx. I'm your host, Dr. Tess Skirm, and in this podcast series, we'll be interviewing an array of industry experts on emerging technology from IDTechEx. IDTechEx is a market intelligence company with a mission to provide clarity on emerging technology. In each episode, our analysts will be discussing all kinds of topics, everything from virtual and augmented reality hardware, autonomous vehicles and flying cars, sustainability and energy storage innovations, medtech and wearables, 3D printing, advanced materials, and so much more. In each interview, we will explore what the future outlook is for each of these technologies, as well as endeavouring to find that elusive insight into hype versus reality. The topic of today's episode is electric vehicle charging. This is an area I'm sure many will have an opinion on, but how much do we really know about how charging infrastructure is likely to change? And moreover, how could this differ globally? IDTechEx is forecasting that the EV charging market will value more than $123 billion by 2034. So I've plenty of questions to ask today's guest, an expert on this topic, Shazan Siddiqui, about what is driving all of this growth and what trends to start looking out for. Shazan, welcome to the podcast.
Hi, Tess. Thanks for having me.
Yeah, thanks so much. So it's a super engaging topic and one that I'm sure, as I mentioned, lots of people are going to have an opinion on. So why don't we just start at the very beginning? What is EV charging?
Yep, I guess that's, the most important thing to realize when we start talking about EV charging is what are we even trying to charge? So like the name suggests, it's a charging of your batteries within your electric vehicle. So if you really think about it, what are EVs? They're essentially big batteries on wheels. And like every battery needs charging, so does your EV. So EV charging is basically activity of supplying electricity, either in AC or DC format, to these battery packs that are within your electric vehicles. And now this can happen at various speeds and various places. And so that's really what EV charging is really all about.
Yeah, so this DC versus AC, so kind of as a layman, is it the case that there is this split between application and what type of charging is used?
Yeah, absolutely. So, where people will be charging their cars is going to be very different to where people have traditionally fueled their vehicles. So we're very used to the idea of driving up to a, gas station in the US or a forecourt here in the UK. And, there's a central location where everyone goes to refill and refuel their vehicle. Whereas this is about to change as we're headed towards a transition in the automotive industry with the advent of electric vehicles. So with EVs, you're essentially able to charge them at home because of your existing power supply that comes with every home, So what happens here is that at home, you are limited by single-phase electricity. And in some cases, you can upgrade that to three-phase power as well. And you'll be using AC home wall boxes. And these are typically limited in power output as well to about 7 kilowatts. Now, you can upgrade your three-phase electricity output by just contacting your local electrician and installing up to a 22 kilowatt AC level 2 charger, what we call it in industry. Now, these, like the name suggests, they slightly higher power, up to 22 kilowatts. They cost a bit more than your level 1 charger, but it's really for those really enthusiastic EV owners who want to charge their EVs at, blisteringly high speeds at home. But then again, all of this really also changes when you start thinking about the fact that, right, I'm going to be leaving my home and I want to be driving to work, driving across country. And that's where public DC chargers come in. And like the name suggests, these use direct current and alternating current. And they bypass what's essentially known as the onboard charger within the vehicle. So with the earlier two examples, like I talked about, the level 1 and 2 chargers, they require the use of what's known as an OBC, an onboard charger. So this is essentially a small unit within your electric vehicle that converts the AC that is supplied from the mains into DC that is used by the battery packs and all the other components within an EV. What the level 3 chargers are doing is that they're taking that OBC that's on the vehicle and putting it and integrating it within the charger itself, and they're bypassing the OBC needed on the vehicle. And with this, you can typically supply much higher power levels, all the way from 22 kilowatts up to 350 and now even 1,000 kilowatts. Right. But as you can imagine, this is very capital intensive. These are, public infrastructure sort of devices, and we're never going to see these, being installed anytime soon in any residential settings or anything like that. That's really the segmentation of where AC charging market currently is. You have your level 1 and 2 AC chargers, and then you have your level 3 and plus DC chargers, which are mostly used in a public setting.
And is charging speed with those categories comparable, or is there a difference already just within these subcategories?
Oh, there's definitely a big difference. So like I was saying, the level 1 and 2 chargers are, of course, in fact, the segmentation is done based on the power output. So for the everyday EV user, all they really care about is the charging speed, because the faster, the higher the power that can be supplied by the charger, the faster you can top up your batteries.
Right.
So for you and me, all we really need to worry about is, I'm going to go up to a public charger. Is it a level 1, 7 kilowatt charger? Is it a level 2, 22 kilowatt charger? Or is it a really nice ultra fast level 3 charger, which is really going to top up my batteries in, the 10, 15, 20 minutes? Yeah. So for us, that's really what we're looking at. And the power differentiation is something to take into account when looking at different chargers.
Yeah. So just touching on that, that super speedy being in the 20-minute category, kind of playing devil's advocate. I suffice to say that certainly kind of me and many people in my family would fall into the category of, on a long journey, we're happy enough to stop off for a coffee break anyway. So 20 minutes feels a perfectly reasonable time to kind of leave the car charging. But there are cynics out there, aren't there, who kind of feel that 20 minutes is pretty long time. So kind of on the nose question, can we expect things to get very much quicker?
Yeah. So first of all, it's a really good point that you raised, because it's like you correctly mentioned, there still will be cynics who will say that even the 20 minutes isn't fast enough. I could top up my petrol car in 5 minutes, in under 5 minutes. Really, you're kind of pushing the envelope of physics here when you start going beyond 350 kilowatts with cars. And, simple physics terms tells you that, as the power requirement increases, your voltage current levels increase. You're talking about more heat management. You're talking about thicker cables. Really, the infrastructure can be built. And we're seeing that with the advent of megawatt charging, So the industry is pushing for faster and faster charging rates. They're building like these 1,000 kilowatt chargers. But really, if you ever see one in the public, and I've been fortunate enough to see these on my travels across various events, they're really heavy cables and really big connectors that the average person just would not want to be dealing with,
Right.
I would feel very unsafe walking up to a megawatt charger knowing what I'm about to touch. The plug itself is supplying, close to 1,000 volts and over, 1,000 amps of power. So, these things are best kept out of public sort of access, and megawatt charging very much will remain an industry niche where it's used for the heavy duty industry where, you already have some sort of health and safety and standards and practice where, the operators aren't necessarily going to, be worried about those safety concerns as much.
Yeah. So kind of lorries and trucks and those kind of vehicles, is it?
Absolutely. Yeah, exactly. Whereas I think for you and me, the average EV user, a level 3 charger that we're now starting to see pop up in a lot of these public EV charging parks, those are, absolutely the sweet spot in terms of fast charging is my personal opinion. Okay.
So is the crux of it then for those kind of normal EV drivers, so the likes of you and me, if we were the type to feel nervous about kind of buying an EV at the moment because we'd have concerns about range, is the pressure more on then the kind of the battery capacity side than the charging speed side? Or is that too simplified?
No, I wouldn't say so. I read a really good quote and I've started using it extensively in my own work as well. And it says, so in the EV charging industry, we've gone from range anxiety to now charge time anxiety.
Right.
There's a clear shift there. Okay. So earlier, yes, when EVs first started becoming mainstream, everyone was worried about the range, and the actual focus was on increasing the range that can be squeezed out of the battery pack. So there was lots of, engineering innovation on the actual battery pack and the EVs themselves. But then slowly the narrative shift from that to the infrastructure itself, and people started wondering, all right, what can we do to actually supply power faster and faster and let the batteries accept this power at a faster rate as well. So now really the EV consumers' anxieties around charge time. So like you correctly mentioned, when we're stopping at service stations, things like that, we're more worried about, right, how long is it going to take to top up from my 20% depleted battery to go up to a healthy 80%? And so, there's a clear shift there in terms of what the average user is expecting. So the range really isn't an issue anymore with electric vehicles. Most of them are now offering, usable ranges of around, 200 miles. But really the anxiety comes with, right, what charger am I going to be able to find? Is it going to be broken? What payments method does it use and things like that? So those are really the public sort of pain points that still exist.
Yeah, I wanted to ask you about that. I saw in your report on the topic about these pain points of not knowing where a charger is, finding it just to find that it's been blocked by a non-EV, and then kind of payment methods not being accepted, which feels to me like less of a kind of charging technology problem and more of just a infrastructure logical implementation issue. So is that still kind of widely prevalent then, those problems?
Yeah, I mean, things are getting better as EVs become more and more mainstream. There's a lot of, good examples out there of, things being done the right way. And again, this comes from just two things, in my opinion. It's consumer sentiment and also, some sort of regulation. So with these two drivers, you can really easily fix these public charging pain points. So, when it comes to, and within my report, I boil these down to three things, which is localization. That's being able to find your chargers, access, which is making sure that once you've found it, that you're actually able to, park in that slot and be able to plug in your compatible EV. And the last one being charging experience, which is, making sure the actual experience is seamless. You're not worried about different payment methods. You don't need to carry around like 4 or 5 different RFID cards and things like that. It should really just be a simple act of, I'm going to plug my EV in, the charger communicates with my vehicle, the vehicle communicates back, and the charging process begins. And I'm automatically billed for the amount of energy I've consumed based on a linked wallet that is associated with my EV. So really, the way I see it is that, these three things still need working upon. And like I said earlier, there's still, good industry examples out there of people doing things the right way. It's just about mass market adopting those examples and then, really helping the industry, implement these best practices.
Yeah, it makes a lot of sense. I can't imagine much more annoying than investing in an EV and then finding it's a nightmare to use for all of these kind of non-battery related problems.
Absolutely.
So the other element I wanted to touch on, and I guess it's somewhat related to the speed of charging, but also beginning to think about how things vary by geography, is I have an understanding that battery swapping in China is this massively popular method of overcoming some of the issues. So what do we need to know about battery swapping, and could we expect that to come into perhaps the European or the US markets eventually? Yeah.
I'm glad you raised the topic because I personally find the topic really interesting. So I'm always happy to talk about it. But that's, the European audience and the Western world isn't so keen on it. And I'll jump into why that is.
Okay.
So, battery swapping, essentially, let's start with what it is. Like the name suggests, it's instead of charging your battery like we've been talking about so far, it's about replacing the depleted battery entirely and putting a fresh battery back in. And really, to give you a simple analogy, Tess, think about the old Nokia Samsung phones with, those back plate covers that we could remove.
Yeah.
Do you remember the times where instead of plugging your phone in, you could simply just remove the plastic backplate and just quickly remove the small lithium-ion battery, just pop a new one in?
I do.
Exactly. So that's essentially what battery swapping now is, but for the automotive industry.
I see.
Now that's really simplifying the idea. And of course, there's a lot of technical sort of machinery that goes into implementing this on the automotive scale. But really, the reason it came about is, again, China spearheaded this technology purely because of its electric vehicle penetration within the commercial vehicle segment. So China started regulating the use of EVs in its taxi fleets in big cities like Beijing and Shanghai. And what they quickly found out was that, these cars need a quick turnaround time. They're essentially useless if they're sitting on a forecourt charging for 20, 30 minutes multiple times a day.
Right.
And the sentiment was largely agreed upon by most taxi drivers as well. They said, this is eating into our revenue generation. I should be out there on the road with customers in the back making money and not sitting on a forecourt charging.
Right.
So really the industry had to come together and find a solution to address this issue. And yes, they could, start implementing and putting up really fast charging public infrastructure. But China had a different idea altogether. They really went ahead and said, why charge it when you can change it? And really that's where battery swapping was born. So they found out that, we could just have spare batteries lying around in a station that is almost the size of a car wash. And by using robotics and machinery, we can essentially let these taxis drive into a battery swap station, BSS, as they're known in industry. And we can have a robot pluck this, depleted battery from underneath the chassis and put a fresh one in. And your car is literally in for under 5 minutes and it's driven out. And really that transformed the industry because it was widely accepted by most of these taxi drivers, and they really loved the idea of, being able to drive into essentially a car wash and get a fresh battery pack for a minimal fee as well. But really what people did not notice is the capital side of things. So these swap stations are extremely, as you can imagine, expensive to install and maintain and implement. And really there's also technological barriers in that the robotics and the machinery involved within really needs to be looked after.
Right. Okay.
So those are the sort of things that battery swapping really brought about and some of the challenges still existing in the industry.
Okay. So if in perhaps the UK or Europe, it wouldn't be, a quick fix to retrofit or modify a petrol station into a battery swapping station. That would actually be something that was not just expensive, technologically complex, but how does it also impact kind of which cars are compatible with having, battery swapping done? I guess you need to have engagement from a specific automaker as well, right?
Yeah. Absolutely. And the beauty with China and why they were able to implement this is because they, a lot of the EV OEMs actually came together, built a consortium and said, let's agree on the fact that we don't want to just be able to charge the vehicle, but also change the batteries on request. So they essentially built a standardized, platform from which these batteries could be exchanged and, swapped out. So very good point that you raised there. This is something that China was able to achieve, but can we see similar implementation across the Western OEMs in the, Western part of the world? Really what we see here is that, the battery pack and the IP around it is something that all of these Western OEMs hold really close to their chest.
Right.
Tesla would never want to share what it's doing with its battery pack with the likes of, Ford and VW and things like that.
Okay.
So we can't really expect them to talk to each other the way that these Chinese companies were able to and really come to an agreement on the kind of platform they want to use. So that's one of the first biggest hurdle for battery swapping, in that the cars need to be, compatible. And for the cars to be compatible and for this to become a standardized infrastructure that multiple EV OEMs can offer, they all need to essentially use the same battery packs and the same platform, which is just something that is very, very hard to expect from that Western OEMs, because that's really where they're differentiating themselves, aren't they? Because if you think about an EV, they're all very similar. You have an electric motor, you have a battery pack, you have some power electronics. But really the differentiating factor comes from what kind of batteries are you using, what kind of battery pack engineering have you done, what kind of thermal management solutions are you using. So it's really about squeezing out as much efficiency and power as you can out from that battery pack.
Yeah.
So for companies to be able to collaborate on that and use one technology, that is just something I don't see happening. Okay. So battery swapping is great for, like I mentioned, the commercial vehicle industry, where your focus is on turnaround time and, the technology itself doesn't need to be as, cutting edge or bleeding edge. So where I see battery swapping thriving is also the micro EV industry. So things like your 2 and 3 wheelers and things like that.
That's what I wanted to ask you about actually was, is there any hope for it to have more success in something like a micro EV market?
Yeah, absolutely. In fact, what our battery swapping report actually covers is that the biggest opportunity and the biggest, segment of transport that can benefit from battery swapping is the micro EV market.
Okay.
And what I mean by the micro EV market are your 2, 3 wheelers and your micro cars. And these essentially, use smaller batteries that can easily be replaced without the use of, expensive robotic machinery. You can essentially just pluck a battery out from under the seat of your 2-wheeler and replace it with a fresh battery. And these batteries usually weigh about, 10 to 15 kilos. So the average user can easily, lift these and put a fresh one in.
Yeah.
And to give you examples from the real world, there's lots and lots of activity within the battery swapping market, in the 2 and 3 wheeler industry, in the Asia Pacific markets.
Okay.
And there's lots of big players there. And there's really a big push from the government side as well to really use this technology within those markets.
Okay. Gosh, it's all politics at the end of the day, isn't it? Some of the reasons for these technology differences.
Yeah.
So going back to kind of the more traditional EV charging market that we were discussing. Mm-hmm. So we've touched on the impact of something like battery swapping. What about some of these other technologies we hear about, like wireless charging or robot charging? Are they kind of slightly doomed to stay niche as well?
Yeah. So again, these are really interesting alternative emerging charging strategies that are coming up as well. And we do have, we do try and cover them as part of our, EV charging research here at IDTechEx. But what we're seeing is that there's very, very little adoption of these technologies currently. And it's primarily because, there's of course technological and economical hurdles, but also because the industry itself is very nascent. The way I see it is that these are technologies which are kind of ahead of their time almost. When I research these technologies, I'm always envisioning a future where there are autonomous robo-taxis and autonomous shuttles, and, we're trying to reduce the human intervention with the use of wireless charging and robotic charging. And that's essentially the idea behind those two technologies. So really, I don't see them taking off in the market till we have robotic autonomous taxis and things like that. And really the idea behind those two technologies is, like I said earlier, it's trying to remove that element, that human element. So the car should just be able to pull up onto a wireless charging pad and be able to start receiving charge in the case of wireless charging. Or in the case of robotic charging, you actually have a robot that plugs in your connector for you into your vehicle outlet.
Yeah. It's interesting that obviously you see the impact of something like autonomy as longer term. What is longer term? Because obviously when I've kind of chatted with other analysts within the company about the kind of autonomous vehicle trends, kind of what I've been hearing is that actually some of the advancements from level 1, 2, 3, are kind of very much of the moment, trends to watch now. And there's obviously, a lot of people as well looking at the V2X and the connected vehicle space as well. So what timescales could we perhaps expect the autonomous trend to start impacting the charging trend?
Yeah, I think there will be a slight correlation in that when we start seeing the wide scale deployment of, autonomous robo-taxis and robo-shuttles, that's when these wireless charging and robotic charging technologies will really start to take off and enter the market on a wider scale. And really the time frame for that, again, I'm not too familiar with how quickly these are going to be hitting the market, but from what I researched and what my sort of research tells me is that currently even the pilot sort of programs where you're testing these, autonomous shuttles and things like that, they're still being plugged in, which I find so ironic.
Right.
So you have this vehicle that, is great. It drives around autonomously all day and it's, battery powered. But at the end of the day, when it comes back to the depot, there's actually a human waiting for it who has to charge it in and, run diagnostics and things like that. So I find that quite amusing. And I think once we see wide scale deployment beyond the pilot phase, now whatever that time scale may be, that's when we'll start seeing those charging technologies rise.
Yeah, it totally makes sense. I guess it was like you saying with the demand coming from the taxi drivers not wanting downtime. If the whole motivation for widespread autonomy is to have, less cars on the road, being more efficient, shuttling us around, then that demand for quick turnaround will come. So I've got a really interesting interplay between those two.
Yeah.
So back to perhaps the valuation that I picked out at the beginning. So this expectation that EV charging could be hundreds of billions of dollars by kind of, the 2030s. Which industries are going to be capturing all of that value in this opportunity? Is this going to be kind of lots of value going into the pockets of the energy suppliers, the charging network operators, the automakers themselves, or is it not clear yet?
So it's an interesting question. Really, we call them the charging value pool chain. So
okay,
there's essentially a little bit for everyone to grab,
right.
is how I would put it. And this is why this industry is so interesting. And this is why so many people are interested in this industry, because really the value starts very much upstream. So all the way from the energy supplier who's going to bring that, who's going to look after the generation and bring the power down and, supply it to your forecourts, to the actual hardware suppliers as well, who are going to install and, look after the hardware, to the people actually operating it as well. So these are your MSPs, your mobility service providers. So they're the ones who commercialize these services and make the app and, handle all the front end. They look after the customers coming in and things like that. And then, of course, with this comes a big, service market as well. So where are these chargers going to be located? They are going to be located in, areas with small, restaurants, or perhaps outside supermarkets and things like that. So you can offer lots of services as well that bundle with EV charging. And to give you a neat little example, the other day I was just waiting at one of my local service stations, which happens to have a few EV chargers. And turns out they have an incentive currently where if you charge your EV for a certain price, I think it was about, over £5, something like that, you get like a neat little 20% off food from inside the gas station.
Classic.
So it's almost sort of, hand in hand trying to give the user an incentive to use an EV charger so you can get some money off your food inside. So there's that services market as well. But
the free coffee incentive is just used in so many technology industries, isn't it?
Absolutely.
People do a lot for a free coffee.
Exactly. And I find that really funny. But so it really tells you the breadth of where the value lies in EV charging. And it really goes from the very top to the very bottom. Yeah. And, but coming back to who is able to, make the most money in this industry, again, it varies quite a lot, but it again depends on the market segment you're talking about. So when we start looking at level 1 and 2 chargers, the actual, hardware makers aren't really profiting that much off that, level 1 and 2 charger, because the hardware itself isn't anything groundbreaking. It's, essentially being sold at break-even prices. The energy suppliers there stand a good, they have a good ground to make money off of that, because you must have seen, a lot of these utility companies now are offering special EV charging tariffs. Yeah. So they are essentially trying to get the users to charge overnight when electricity is typically it's at its cheapest rate, by offering a special tariff. So many of the home chargers are actually, being used on that tariff, and energy suppliers are essentially benefiting off that. Yeah. Whereas when it comes to public charging networks, here again, I'd say the majority of the revenue is being, taken up by the actual, the electric vehicle supply equipment suppliers. So these are your EVSE suppliers and the charging network operators. So these are essentially companies that, install. So first of all, they manufacture the hardware, they install the hardware, they maintain the hardware. And then the companies that actually operate this on the front end, those are the two companies hand in hand making the biggest sort of revenue in the public charging realm. Okay.
Yeah. Well, it makes sense. Yeah. I think the reduced costs overnight, I can see that being quite a big driver for adoption for people, especially kind of the current economic climate. The caveat then being you've got to have had the wealth to begin with to afford quite an expensive electric vehicle. So a tricky one. Okay, so just to finish up then, so we like to talk about on the podcast perhaps areas of technology markets that are either overhyped or underhyped, or picking out the area, is all the headlines in one area when actually everyone should be talking about something else. So in your opinion, kind of what would that be for the electric vehicle charging?
I'd say I'd love to highlight an underrated or underhyped example, if that's okay. And I think that's the advent of V2G, so vehicle to grid. Now this in technology again is very interesting, and to keep it very simple, really how I would explain it is, again, think about your electric vehicle that you've just purchased as essentially a big battery on wheels. When it's just sat stationary, which is most of the time, you can imagine that it's essentially a resource. It's what we call in the industry a distributed energy resource, DER. Right. That's just sat there, with the potential to supply energy back into the grid. So EVs can be seen as a bidirectional source of energy. They're not just, taking power from the grid. In many cases now and in the future, I feel they will actually support the grid. They will be able to put energy back into the grid when they're not being used during times of high demand. So really, I feel like that is one technology to really watch out for. Currently in industry, it requires there's a lot of technological hurdles in implementing V2G. There's a lot of regulation that's needed on the grid side. And a lot of industry players need to talk to each other. A lot of different industries, the transportation industry, the electricity industry, need to talk to each other to really enable this V2G to be successful. But I see it as a really underrated and, a technology that's not talked about a lot currently, but definitely in the future as EVs become more and more mainstream and, every one of us has an EV parked outside our house, you have to start thinking about the fact that we want to keep these plugged into the grid so that the grid isn't necessarily being constrained. And I find that to be a really, really underrated technology as of now.
Yeah, that's fascinating. I haven't heard about that before. I mean, I have to admit my instant reaction is knowing that some people that I know would instantly say, so hang on, I've just charged up my EV and now the grid's going to pinch it back. But I appreciate the kind of, there's this wider demand for much better national scale kind of resource optimization in general. So that's really interesting. So hope to see more information about that from your research in the future. I'd like to
Absolutely.
know more.
I think just one thing to point out here was that, the average person might say, oh, you're taking away some of my energy that I just put into the battery. But you're being paid for it. Think about that. Think about your EV making you money while it's sat stationary outside your house. Okay. I personally think that's a great option. If I'm not using it for, up until the afternoon, I'm okay for it to, in the morning when everyone switches their kettles on and there's a huge spike in electricity demand, I'm okay for, my EV to supply some of that back into the grid as long as I'm being compensated for it. Yeah. So there is that factor as well. But an interesting technology nevertheless.
Yeah, absolutely. A bit like the solar panel schemes and everything as well, isn't it? It's all all very related. Yeah. Oh, well, Shazan, thank you so much. Perhaps just before I let you go, if there's one thing that our listeners should kind of remember about the EV charging market, what should it be? What's the kind of one sentence takeaway?
Okay, one sentence takeaway for the EV charging market. I'd say that we're at, like I started this podcast with, we're at a transformation point in the automotive industry in general. Mm-hmm. And the EV charging market is something that is going to revolutionize the way we interact with our cars. Fantastic. And that's really my key takeaway.
Brilliant. Thank you so much, Shazan.
Thank you so much for having me, Tess.
No problem. Thank you so much for listening to Tomorrow's Tech, hosted by IDTechEx. IDTechEx offers independent market intelligence on emerging technologies. For more detailed information on this topic and many others, please go to idtechex.com, where there are dedicated research reports on the emerging technologies we cover, as well as articles and free-to-attend webinars.